So hello, my name is Megan Carter. I am the Community Director of ESIP. Welcome to this third webinar in the Earth Science Information Partners Data to Action webinar series. Today's webinar will feature a panel of speakers, we're very excited, who will discuss the fourth National Climate Assessment and the task of translating data to inform decisions. This webinar series, which will continue throughout the rest of the year, follows our 2019 theme of increasing the use and value of earth science data and information, which was one of several goals identified in ESIP's most recent strategic plan. Just a few words about ESIP before we get started. ESIP's vision is to be a leader in promoting the collection, stewardship, and reuse of earth science data, information, knowledge that is responsive to societal needs. By connecting people across the data lifecycle and across sectors, ESIP helps people to leverage their collective expertise and their technical capacity to address challenges related to the creation, management, distribution, and analysis of earth science data. For more than 20 years, ESIP has helped members of the earth science data community find each other across organizations by fostering rich collaborative experiences like in-person and virtual meetings, and through seed funding to further data interoperability. ESIP is funded by NASA, NOAA, and the USGS, and currently has more than 120 partner organizations spanning the federal, private, and academic sectors, as well as many more individual participants. Now I would like to introduce you all to Erika Virapongsi, Principal Scientist at Middle Path Eco Solutions, as well as Chair of ESIP's Community Resilience Cluster. Because of her expertise and interests, Erika was a natural choice to moderate today's webinar. So with that, I'll pass it off to you, Erika.
Thank you, Megan. I'm really pleased today to be able to moderate this webinar around the fourth National Climate Assessment. And I'm just going to give you a little bit of background about the assessment itself. They're organized by the U.S. Global Change and Research Program, otherwise known as US GCRP. And this climate assessment process is mandated by law through the Global Change Research Act of 1990. This act mandates that a report is submitted to Congress every 4 years. And its goals are to integrate, evaluate, and interpret the findings of the program, and 2, to analyze the effects of global change on the natural environment, human use of land in the environment, and society at large, and to 3, analyze current and future trends in global change. This is the fourth National Climate Assessment, so that follows from previous reports that were published in year 2000, 2009, and 2014. It was published as a 2-volume report. So the first volume was entitled the Climate Science Special Report. It was released in 2017, and notably, its findings were that it is extremely likely that human activities are the dominant cause of observed global warming since the mid-20th century. The second volume was released in 2018, and it was entitled The Impacts, Risks, and Adaptation in the U.S., and it was noted that human health and safety and quality of life is increasingly vulnerable to the impacts of climate change. So I'm very pleased to welcome our 3 speakers today. They're going to be speaking on a range of different topics, ranging from how data is brought into the National Climate Assessment, provenance of that data information, and the dissemination of information among end users and decision makers. And so with that, we're going to have Dr. Dan Barry as our first presenter. He is the program manager at NOAA, the National Oceanic and Atmospheric Administration, at the Climate Program Office, and he manages modeling, analysis, predictions, and projection programs. So with that, I'll hand it over to Dan.
Great, thanks a lot, Erika. Can you hear me well?
Yes, you sound great.
Okay, great. And you can see my slides okay, as well as this little laser pointer?
Looks good.
Perfect, thanks. Well, thanks for the introduction, and Megan and Erika, thanks to you and the ESIP program for the invite to speak. I'm really happy to have the opportunity to tell you a little bit about the assessment. Erika did a nice job of introducing the legislative mandate for the assessment. I have a few slides on it. I think I'll just add a few points to what she said, but then what I'm going to do is dive into a number of examples of how data was utilized in the assessment and the importance of various types of data to the assessment process as the theme of this program and the webinar series. it was mentioned that this is an assessment that's required by law, the GCRA. And one thing that I want to add to what Erika said is that there's not really much more language in the law than how she described it and what's on this slide here in terms of what's expected from the assessment. So there are a variety of things that we know we need to do when we produce the assessment, but there's quite a bit of bandwidth and space in which the assessment has developed over the years into something I think even more robust and significant than even what the law requires. You know, the law is almost 30 years old, and so there are quite a few different elements of climate change that we're increasingly aware of and need to look into, including intersectional issues between different sectors and where there can be interactions between various physical systems and economic sectors that can drive nonlinear or unexpected change in the climate. So there's a lot of development and thinking that has gone on over the years to sort of expand what the assessment is looking at. And there's both a historic element to the assessment as well as a future-facing element. So the law actually calls out that the assessment should look into the next 25 and 100 years into the future at the projected climate impacts in the United States. And so this brings in, both the need for observational historical modeling and descriptive data sets, as well as future-looking projection data sets where there's quite a bit of, model data that's utilized. And these are the reports that were mentioned in the introduction. So we had this most recent report that came out in 2 volumes, the first of which on the left, the Climate Science Special Report, came out in 2017 and the most recent one in 2018. And there are a variety of new elements of both of the reports. The Climate Science Special Report is largely focused on the physical climate system and evaluating physical climate changes, so things like temperature, precipitation, phenomenon such as drought and other types of extreme events, and monitored changes in carbon dioxide, and then also looking into the future at scenarios of potential growth in carbon dioxide and other greenhouse gases, aerosols, and their effect in forcing the climate to change. So it's very physically based. If you're familiar with IPCC, it's sort of akin to the Working Group 1 effort in the IPCC. And then the second volume on the right-hand side, quite a bit longer. It came in around 1,500 pages, and it's sort of akin to IPCC Working Group 2 and much more focused on the ways in which those physical effects of climate change play out in terms of impacts in society, in the economy, and across sectors in the United States. And I put a few bullet points up here. I'm not going to belabor them, but they're essentially trying to depict some of the things that are unique or new about each report. The Climate Science Special Report in particular was a real ramping up of activity from previous assessments to look much more robustly and deeply at the climate science element. So climate science is, the science element is of course very important to the assessment to undergird the discussion of impacts. And in previous reports, it was largely integrated as an appendix or a chapter, but in this case, it was given a full independent treatment as a volume of the assessment. And so the level of detail and discussion is much higher. So that's something that's really pretty new about this assessment, is the level of focus on the physical climate aspect. And a number of different elements, including climate model weighting, which is something I'll give some attention to later in the talk. One thing I want to mention about volume 2 of the assessment is that this report is intended to be a summary of knowledge about climate change and its effects in the United States. So it's not actually making prescriptive policy statements in terms of we should or should not do these things to address climate change. It's really just trying to assess the nature of climate change in the United States to give policymakers a clear idea of what type of policies they may want to pursue based on that knowledge. But we're not making recommendations about policy. So the way this is often expressed is that it's policy relevant, but it's not prescriptive to policy. And I also want to mention, it's great Leslie Ann's on the phone because she's going to talk about, some of the regional perspectives as well from the report. But one thing we decided with the assessment this time was to focus much more on regions in detail, to really allocate our page budget towards giving a better regional sense and a more detailed regional sense of climate and its impacts because that's something we had heard coming out of the third assessment that stakeholders and individuals who consumed the assessment really were desirous of. So that was a significant increase in emphasis on the regional component in this report. So what I'm going to do for the remainder of the presentation is give some examples of the use of data in the assessment, in both volumes of the assessment. And as an intro to this, I tried to break down the types of data in the assessment into some categories. And the first one, of course, is observational data. So in situ measurements of parameters like temperature, precipitation, pressure, stream flow, a variety of other relevant physical parameters. And these can be measured both in situ and in some cases from satellites to provide, more homogeneous or better coverage in time and space for some of these parameters. And then also paleo, climate, and proxy data sets that try to extend the record of the physical state of the climate back to the period before we had both satellite and in situ measurements taken over much of the globe. Model data is very important, as I mentioned. Of course, it's critically important looking out into the future. It provides the basis of a lot of the discussion of expected impacts in the climate in the United States in the future. Many other records, so case studies are really critical, especially in volume 2, to give anecdotal sense of felt and experienced climate impacts in different sectors and regions. Also ideas of how communities respond to extreme events or are planning and trying to build resilience in their communities to future expected climate change. Data rescue is something I would love to spend a ton of time on because it's such a cool topic, but I'll just mention it briefly that there are all of these records out there in logbooks from ships and even medical records where there happens to be quite a bit of data on temperature or sea level pressure. And so there are a lot of efforts as well to try to rescue this data, to digitize it and bring it into the observational and modeling world to better use it and extend our records back further. And the assessment leverages that data as well. Socioeconomic data and economic studies are really important to understand how economics tie in with physical climate change. And then different fusion examples. And in the interest of time, I think I'll just move on to the specific examples that'll get at some of these fusion uses of data. So starting out with an example of how observations are used, this is a graphic, the first figure in volume 1 of the report, and it shows 9 different examples of physical parameters tracked by observations over various time periods. And looking at the 3 on the left, from top to bottom, you have land surface air temperature, sea surface temperature, and sea level. And one thing you might notice is in each case, there's multiple data sets that are utilized to describe each of these variables. And this really helps give a sense of observational uncertainty and robustness of the measurements. So in many cases, the assessment tries to use as many lines of evidence as possible to get a sense of uncertainty and the robustness of conclusions that are drawn from these data sets. And you can see in the plots on the bottom right as well, in many cases, there are multiple data sets when they're available to help give a sense of the uncertainty bounds of the measurements of these parameters. This is an example of paleo records that go back to about 2,000 years before present. And these are very useful to try to contextualize the rate of change that has been experienced recently in a variety of fields. Here, this is temperature. These are temperature reconstructions. And as with the data on the last slide, you can see that there are multiple different data sets used here to provide these uncertainty boundaries. And you can see the uncertainty is quite large on the data sets. If you look at the Arctic one on the top left, for example, there's quite a bit of uncertainty bound around the mean of these different data sets. But these bring together tree rings and ice cores and speleothems and lake sediments to try to describe as robustly as possible paleoclimate, so that you can contextualize much more recent change relative to that, which has been quite rapid. In some cases, observations can be combined with analysis techniques to get at new descriptions of factors. In this case, this is an example of fingerprinting the climate signal. So you might start with global surface temperature, and you can look at this record. There's some trend in there, but there's also quite a bit of noise in the record. And so you can start to think about how to remove some of the components that drive global surface temperature to get a cleaner description at the end of the human contribution to the global temperature record. So you might start with the solar component and the variability of the solar cycle on decadal timescales and subtract that out. And then you can look at the volcanic influence and subtract that out, where there's very significant but short-term impacts from volcanic eruptions on global temperature. Natural variability, things like El Nino and La Nina, you can subtract that out. And once you take all of these different factors out, you're left with this longer term component, the human, generally the human contribution over time from greenhouse gas emissions and the buildup of greenhouse gases and aerosols in the atmosphere. A specific example, you could look at the 1998 El Nino, which led to a very large spike in temperature that's reflected in the global surface temperature record. You can take that out. Or the Pinatubo eruption in 1991 and subtract that out to help smooth the data and look at the various components. And then finally, in terms of modeling, this plot is showing the utilization of models in the climate science report. Each of these different logos is a different model. In some cases, there might be a center like the Hadley Center in the UK that contributed 3 different models to the model experiments, but there are many different centers around the world and a variety of different models that contribute. And you might ask the question, how do we most optimally use these models? Some models perform better than others, and so that's something that's estimated here on the vertical axis. The models towards the top perform better in the historical record than the ones at the bottom. But then also, how similar are these models? So if one modeling center contributed 10 out of the 50 total models, it might bias the results towards the future that that one particular model anticipates, which isn't giving you a really robust sense of the possibilities of future climate. And so this x-axis sort of answers that question of how unique is each model, and it'll give a little bit more weighting towards more unique models and less weighting towards less unique models. So now jumping to volume 2, a few examples of data in volume 2. This is a very similar graphic to the one that I started with. These are observed changes in the climate, but it starts to get at some parameters that are more relevant to society and socioeconomic situations. I use this one on the top right as an example. It's a little bit small, but it's basically showing what's called heating and cooling degree days, which is a way of aggregating temperature to start to get at the energy load that you expect for energy systems because of warming summers demanding more air conditioning and warming winters demanding less heating resource. And so you're starting to kind of bridge from just looking at raw temperature into something that has more of a social consequence or an economic consequence, particularly in the energy sector in this case. And these indicators are actually maintained by the US Global Change Research Program. So this serves as both an on and an off ramp to the assessment. It basically maintains the data resource for some of these parameters between the 4-year cycles that were mentioned in the introduction, so that we can look at changes at a higher time resolution, an annual time resolution. This is a really nice example of a fusion between risk exposure and geophysical change. So the blue to white colors show the risk of sea level rise and flooding from various hurricane events. Dark blue is essentially a Category 1 hurricane, whereas white is a Category 5 hurricane. And this is showing the Charleston Peninsula, the flooding you would expect from these events. And the dots represent where there are hospitals located in the Charleston area, the color of the dot representing the level of hurricane that would cause a risk to that hospital. And red is basically a Category 1 storm. So you can see the hospitals in the Charleston area are quite vulnerable to even a Category 1 or Category 2 storm. And a similar picture in Miami-Dade County as well, with significant risks closest to the coastline and lesser risks. You would need a Category 4 or 5 storm to impact some of these inland hospitals. This is an example of records of marine species, and on the left it's showing how they are shifting northward over time, which impacts communities that depend on fishing these various resources. On the right, this is showing the biomass in tons that are caught per year of these resources, and you can see some pretty strong trends. So this shows both a climate risk, but it also gets at management decisions as well, where, at NOAA, for example, we set catch limits on fisheries so that we try to prevent the collapse of the fishery in response to both fishing pressure, but physical environmental changes as well. And the final example, this is an example of response to climate change. This is from the mitigation chapter. Each dot on this map shows a community that has taken some mitigation action. The colors of each state indicate the number of mitigation-related activities at the state level. So California is taking quite a few actions, and some other states as well are very active. And then the bottom here shows state by state how many mitigation level actions are taken at the state level and divides them into categories like energy efficiency or transportation issues. And it also shows the breakdown of the NCA regions, these black lines, the Northeast region, for example, here. I'll just leave this here. These are the links to find all of this report content. And I want to thank Dave Riedmiller as well for providing some slide content.
Thank you so much, Dan, for that presentation, and particularly for contributing some insights onto how the data is, how these diverse data sets are integrated into the climate assessment plan and what that really means. So our next presenter will be is Dr. Reed Sherman. He's at the U.S. Global Change Research Program, US GCRP. He's in the National Coordination Office, where he manages the Global Change Information System and coordinates efforts on data management and providing climate information for adaptation and resilience.
Thanks for the introduction, and thanks for inviting me to speak today. So Dan set this up nicely by talking about the different kinds of data and information that are incorporated into the assessment. And what I'd like to talk about is how the assessment as a web presence surfaces a lot of that information to really add value to it as a product. And so, we really try to achieve what we call traceable provenance. And so first I want to talk about why we need traceable provenance. And it's for three major reasons. The first is that it increases the credibility of the report. This both, demonstrates scientific integrity, and it's also, as folks in the ESIP community would know, the scientific community is moving more towards stricter standards on data management and data and metadata standards, and so we want to meet the highest standards possible. The second major reason is that it enables reproducibility of the report, that the research done to make this assessment will be reproducible, and as a government product that will have the greatest transparency possible, so that for instance, if this shows up in any court cases or something, that it's easy to trace the source of all the information. And the third reason why we need traceable provenance is so that this report can be used to inform decisions. That when you can trace information in the report back to its source, you can get customizable data and information for your needs, even if it might be related but not exactly what's specified in the text of the report itself. So the ideal for this is for traceable provenance sort of goes through a few steps of value and difficulty. The first step is traceable sources, meaning the citations and sources, previous publications that are cited, having those be traceable. The next step of difficulty is the data that was used being traceable. The step of difficulty beyond that and value is the processes used to create the assessment. And then the last is traceable tools. What actual technological tools were used to make the things that you see in the assessment. So I'd like to show some of this off. First, for context, I want to show some standard practice of what is often seen in other assessments, and this is not at all to denigrate them, but just to have the contrast and show the extra work that was taken on our part. So this is a figure from the IPCC Working Group 1 report, as seen in in Chapter 3 of it. And so you see a figure And if you look, blow up the caption, you look in the caption, you see that there are citations there. And if you flip through the report and find the back of the chapter, you see the citation in the caption of that figure like this. And so you can find the source of that information, but it does take quite a bit of work on a reader's part to then go, find that journal, read through the article and figure out how whatever data was in that paper was made into this figure. And so I want to show what we try to do in NSA 4 as steps beyond that level of traceability. And so we do this in 3 ways that I'll talk quickly about each one. The first is what we call traceable accounts. The second is that we have our sources and citations linked, and then with the metadata about the publications that are cited. And then the third is that the figures in our report have their data and processes documented. And all of this is captured and managed by the system that I oversee called the Global Change Information System, which is an open source system that links together all these bits of information and also traces them over time so that you can see, so that you can not just trace the source of information, but also see what other things that information has produced in across our current assessments and past assessments. So the first is traceable accounts, and this is sort of a piece of each chapter. If you are looking at the website and you see the sort of menu, the table of contents on the right hand of the page for each chapter is sections. This is an example from chapter 6 on forests. So you have executive summary, information that key messages, sort of each different topics about the chapter subject. And then at the bottom, just before references, you see their traceable accounts. And what that is sort of a detailed description of how the how the decisions were made about what the key messages are, and how certain we are about the conclusions. So on the right-hand box, the pieces of each traceable account is that there's a process description which sort of describes how the author team worked. And then for each key message, there's a description of the evidence base, major uncertainties, and description of confidence and likelihood. And sort of each of these is really laid out in detail and has a lot of sort of extra citations that are that help give more credibility and more citations and sources to see where these conclusions came from. So the second piece is our citations being traceable. And so here from the chapter 6 on forest is a random paragraph picked out with plenty of citations in it. And when you're on the website, if you click on any one of them, you get a little pop-up window that gives the citation, including, importantly, a DOI there, so that which you can click on and go straight to the paper, so that it's very easy to, with just 2 clicks, go straight from reading the report to the source of the information that you're reading about. And we cite all the National Climate Assessment cites all sorts of different publications. So not all of them are from journals that assign every paper a DOI, but as a example in this chapter that I'm pulling examples from chapter 6, there are 182 citations and 175 of them have either a DOI or a URL leading to the source. So really the vast majority of citations in the report are easy to find with a click or two. Also, just as additional information, if you actually go into the web presence of the Global Change Information System in GCIS and look at any one of these citations for Volume 1, for Volume 2, we're still working on this level of traceability. You have a whole record of metadata about that publication, not just the journal and citation and DOI, but also records for all of the authors that wrote that publication and the institutions that they were at for that publication. And so you can really get a lot of detail and linking together of where the information came from that you're seeing in the assessment. And then finally, but possibly most importantly, the sort of extra traceable provenance we have for figures. So looking at a figure again from chapter 6, for any figure in the report, you see this little icon next to it, the little eyeball, which takes you to the metadata. And so if you look at this, at this metadata window that pops up, you can get all sorts of extra information about the figure. For instance, you can see the point of contact, who's responsible for that figure, and get in touch with them if you have questions about it. It also gives you lots of extra details if you click on this tab, panel details. You get, for instance, the data set or data sets. In this case, there were 2 data sets that were used to make this figure. Metadata about that data set, its source, a website where you can go to get it yourself. And as well, I'm not going to show you screenshots for everything, but as well as this, there's also analysis methods and tools, which is that point of contact for the figure's description of what they did to the data sets to make the figure, so that you can really go and reproduce it yourself. Or in some cases, it's a figure that's pulled out of another publication and it gives you the citation and what was done, whether it's changing the color palette or something else. So there's really a great amount of detail in what was done to create the figures, so that they don't just have to be believed, but that you can create them yourself or your own versions if you want to subset a different, say, time window or geographical window. As well, just another level of detail is, many of our figures have multiple panels, like you see in this one, and there's all this detailed metadata for each panel. If you go to panel details, you can pull out the data sets used and analysis tools and methods used for each of the panels separately, or download the images of each of the panels separately. So there's really a great amount of navigability and tools to pull out extra information from the things that are in the printed report itself. And then very briefly, I'll just sort of quickly advertise the sort of advances we're thinking about of going even farther in traceable provenance for NCA 5. The first is sort of establishing some quantitative metrics to measure this metadata quality and completeness. The second is that collecting all this metadata is not a easy task. It's a real burden on the authors and a real major effort. But it's very valuable, and so that's why we do it. And so we're improving ways of doing that to lessen the author burden. For instance, making curated libraries that they can select from, so that the metadata is already in good quality shape and deduplicated and things like that. The third is that we have assigned keywords to a lot of our figures and messages, which you can see on the website, but we haven't implemented tools of how to use them as part of the web presence, and so we're working through that for the next time, of having them be suggested searches or navigate through cross-cutting across chapters by topics. And then the fourth is just within GCIS, building our very complicated data model and the technology that does all the back-end work for this, improving that to really match scientific practice and standards and what we need for users of the report. And so I just wanted to before I close, acknowledge first of all, my team here at USGCRP that works on GCIS. Amrutha and Ruben, do terrific work in managing all the content. Kat, I have to give credit to, because she did a tremendous amount of work, but unfortunately recently left for another position. And so we're working on getting a replacement or a successor, because no one can quite replace. And then I also want to acknowledge the NOAA Technical Support Unit at the North Carolina Institute for Climate Studies. They do all the web design of the website and do a lot of the metadata collection and management before it gets into GCIS. And there are too many people in that team for me to name all of them for fear of forgetting a couple, but they just do incredible work and want to acknowledge them. So that's my contact information there, and thanks again.
Thank you, Reed, for that presentation. I think that offers really great really great information into the climate resilient, or sorry, the National Climate Assessment, and a really great behind-the-scenes look at how provenance works. And it's such an important topic today, with so much discussion around what are trusted data sources. So so for our next presentation, I'm going to introduce Dr. Leslie Ann Dupini-Giroux. She's a professor of climatology in the Department of Geography at the University of Vermont.
Thanks, Erika. So again, thanks for the invitation to participate in this webinar. And there are a couple of things that I wanted to sort of highlight. In addition to sort of teaching about a lot of this stuff, I'm also the lead author for the Northeast chapter and the Vermont State climatologist. And so I put on a number of those hats when I was thinking about what are some of the lessons learned having gone through the NCA4 process, and thinking about the various talks that have either given or interactions with the media, and how do we sort of get the word out. So in full disclosure, I've been sort of involved with the NCA since NCA2. I think I was a reviewer on that document, and was a contributing author on NCA3, and now lead author for the 4th National Climate Assessment for the Northeast chapter. And so when I think about some of the pieces, one of the big things is the visuals in terms of how those are used. And so that was one of the things that sort of drove a lot of the decisions that we made for the Northeast chapter. And, as we move to the next slide, and we look at one that I always sort of end up on whenever I give a presentation, a lot of people always say, what can we do? How can we make a difference? How do we use the report? And so for me, this slide is something that I get really excited about, because in NCA 3, when we were working on it, there were a lot of examples that we were considering as case studies, and how do you include them? And so there were a lot of sort of on the ground either mitigation or adaptation strategies that were just coming online and starting to be implemented. And a lot of those are now sort of fully implemented, and new ones being added to that cadre. And so when you look at a graph like this one, you sort of focus in on the middle part of that diagram, you can see the sort of push forward and the progress that's been made since 2014 in terms of engaging with stakeholders and looking at ways that adaptation has taken place on the ground. And so I usually use a lot of the diagrams and the visuals from the report to kind of help folks parse through it, because there's a lot of material. There's a lot of great stuff. There's a lot of underlying data, as you've heard, that went into it. But unless you've actually sort of worked through it from the ground up, it can be a little bit daunting. So I usually kind of weave in as many of these as I can and use them to sort of help people sort of parse through. So like chapter 28 is the adaptation chapter. Chapter 29 is the mitigation chapter, so that they can start getting their heads wrapped around how do we kind of use some of these materials. So as we move to the next slide, one of the things that I had to do in preparation for giving a similar talk like this at the American Meteorological Society meeting back in January was to kind of read through the 10 regional chapters and see if there were sort of threads that made their way through the tapestry that sort of told a coherent story. Because when you're working on a regional chapter, you sort of have your head down, kind of focused on your region, and sort of coming up to breathe for a little bit, kind of realize that even though each region is unique, there are a lot of commonalities across the contiguous U.S., Hawaii and the affiliated islands, the Caribbean, Alaska. All of the various regions have very, very similar stories, and those range from indigenous peoples to how climate change affects human health. And of course, with the exception of some of the landlocked regions, pretty much everybody along the coast talked about the importance of sea level rise and the risks and the vulnerabilities that sort of went along with that. And then the various ways in which infrastructure and transportation are another set of sectors that are particularly at risk as well, and how those are sort of playing out. So as we continue to move through the slides here, what I thought we would do is to sort of use this as a reflection and think about what have we learned both from a process perspective, an outcomes perspective, and maybe an interactions perspective. So one of the things that really, really struck me was how important networking is to the whole process from start to finish. Well, actually before the process starts, because that's where a lot of the information that we use to bring to bear, whether it's data, whether it is the on-the-ground stories, the case studies, a lot of that comes from sort of tapping into the various networks that authors already have in place. And it sort of highlights the role of ongoing activity, not just to ramp up for the NCA as a process, but sort of ongoing networking across the regions. And that really came to the fore with regions that have been doing a lot of this work on an ongoing basis for a number of different years. Another place that this sort of came to the fore was, and this really struck me when Victoria Kina, who was the lead author for the Hawaii and Pacific Islands chapter, when she presented at the AGU, she had this amazing story of being able to have collaboration with the mayor of Hawaii. The Monday after the report was released, there was a press conference, and they were able to sort of give the high points of the report, especially the chapter that she had worked on, and that just sort of cemented for me that need to really be in close contact with stakeholders so that they can help get the word out as the report sort of comes online. So moving a little bit to the outcomes, which is the next slide here, and thinking about who actually uses the report. One of the things that I know from being state climatologist is a lot of the users of the report are actually folks in academia, whether it's in the classes or whether it's in research. And so I think going back to Reed's comment about the traceable accounts, those are like primarily and supremely important because that's where a lot of the gaps in the knowledge are actually captured. And so, and students ask me, what can I do for a research project? That's one of the places I always point them to because it gives them a starting point for where they need to actually sort of drill down and maybe make a contribution to knowledge. The other piece in terms of outcomes is, this goes back to some of the things that Dan was talking about, being policy relevant and policy prescriptive. And, when people invite me to give a talk, they usually want me to talk about climate change in that particular city or for that particular county or a certain part of that particular state. And I know we try to move in that direction in between NCA 3 and NCA 4, and I think I wanted to just sort of highlight that as we move forward and think about NCA 5, that the ways in which we continue to parse through the data, work through them, present them visually, will continue to be one of those sort of driving factors in there. So data visualization is absolutely critical, and it really struck me when somebody asked me a couple months ago, do you remember that figure that we had in NCA 2 that had Vermont and New Hampshire, and they had these large red arrows that showed how the climate would become more like Virginia by 20X and more like Atlanta by 20Y. And that figure is now 10 years old, so it came out in 2009. And that sort of just reinforced for me the importance of how we create figures and how we use them to visualize a lot of the data that we have been manipulating and exploring and analyzing in the background. But how does that final message get told? So one of the visuals that we created for the Northeast chapter is on the lower right-hand side here, and it looks at how does coastal inundation sort of play out, and what are some of the sectors, both physical and human, that would be affected. And as we move to the next slide, these are two that I particularly like for two different reasons. The one on the left is from chapter 24, which is the Northwest chapter, and it is a particularly ingenious way of having all of the key messages that are in that chapter in one figure with the highlights of each key message, and then sort of the progress that has been made since the last climate assessment, both from the national level but also from the regional level, because the Pacific does more frequent assessments than only at the national level. So that's a really, really interesting way of sort of capturing a lot of those key messages in one sort of snapshot. The one on the right is from the Hawaii and Pacific Islands chapter, and the genius here is the use of graphics, in that it's the same visual, but the upper diagram shows you the indicators, so the data that are being explored, and the lower diagram shows you the impacts of what happens when we look at those changes. So again, a very ingenious way of sort of pulling together two different parts of the equation that we're looking at in a way that sort of makes sense from a visual perspective. And the last one that I'll show you, which is on the next slide in terms of visuals, is one of the things that we saw with the use of NCA3 was that when we have one figure, like one number for the entire region, it sort of masks a lot of the spatial variability, both from sort of inland to coast, upland regions versus highland regions versus lowland regions. And so one of the things that we really wanted to do, again in Northeast chapter, was to try and make sure that that spatial heterogeneity sort of came to the fore, so that if you lived in upstate Maine, the conditions there are not the same as in West Virginia, and we wanted to sort of highlight that. So data visualization was key for us. So thinking about those and thinking about the interactions with users, which is on the next slide here, and some of the places and the avenues and the venues that I've sort of presented in, each one reveals something different to me. So the New England federal partners were particularly interested in the data gaps. And one of the data gaps that sort of came to the fore for us as a region is drought, and how we need to sort of work through and explore some of the physical dynamics of drought a little bit more. And so there was some great interaction with the partners who were from FEMA and the USGS in terms of some of the things that they are working on that we may not have known about, and how do we kind of tap into that and work with that. Some of the other things that sort of came out in some of the national meetings, especially the American Association of Geographers meeting last month, where there were a couple of folks from the Sierra Club, and they were really, really pushing for policy statements, and that's where that highlight from the congressional mandate that this is policy policy relevant rather than policy prescriptive becomes critically important, because a lot of times users are thinking that they're going to get a roadmap that has specific policies, specific strategies, and not always understanding that the assessment report is, as Dan was saying, a summary of research on what we understand about climate and climate change to date. Another one that was really interesting, I presented to some members of the International Joint Commission, and the piece that they were particularly struck by was adaptation, because that was not something that they had known a lot about. So I was able to sort of pull a lot of resources in terms of not just the adaptation chapter, but adaptation strategies from around the region here in the Northeast that I could have shared with them. And then finally, last week I was talking to a regional planning commission, and they reminded me I really do need to reach back out to the state agencies, because they are some of the key consumers of the information that we're providing in their report. So the final piece is an intersectoral and cross-border set of reflections, which is on that final slide. And the Canadian Changing Climate Report came out last month, and when you think about the way in which the reports are sort of co-managed, some of the lessons learned across the board, the fact that it's patterned on the NCA4, but there are some key differences, some key ways in which individual groups that are climate-based work on individual chapters, the way in which they have different types of standalone reports. For example, their Indigenous Resilience Report might be something that we can take a look at as we continue to grow and improve the NCA as a process. So with that, I would like to stop. I've got one more slide here, which shows the sort of citation that was put together for each chapter. Give a shout out that echoes a lot of the things that Reed said. We could not have done this without all of the amazing support at both the technical service unit at NCEI, as well as the staff at USGCRP. So my thanks again to all those who've enabled this report to be what it is. And with that, I'd like to turn it back over to Erika.
Great, thank you so much, Leslie Ann. And I'd like to commend Megan for setting up a really great webinar. I think we heard, I think we heard the whole process of the National Climate Assessment and how it was put together, particularly in regards to how diverse data and models are integrated into the National Climate Assessment from Dan, and then from Reed, we heard about how the assessment addresses provenance in the report. And I think these two aspects really speak to the robustness of the report and the attention that was brought to building trust around the information that it presents. And then to segue into that, we wrapped up with Leslie Ann's talk about how all this information can be communicated for use by decision makers. And we just have a few minutes for questions, and I'll just go ahead and ask the question that I've been wanting to ask. And I'm speaking to this on behalf of the Community Resilience Cluster that I chair, and something that we've been thinking about is looking at, or just considering, how the earth science data has been historically produced and curated for scientists, and now we've got this changing framework into science being called to produce information that's usable by non-scientists, and I think that's a difficult task to bring to scientists, because they're not often interacting with end users, and are not trained to either. So maybe if the speakers could perhaps offer one tip, or some kind of word of advice for scientists, or people who are closer to the data generating end of the information value chain, of something simple that they can do to increase the application use of the data that they are producing or managing. You guys can just jump in.
I would say work with your...
Sorry, go ahead. Go first, Leslie Ann.
I would say work with the state climatologists in your state, because that's what their role is, to be the translator of information, knowledge, and science between the creation of it and the stakeholders on the ground who have articulated needs for it.
And this is Reed, and I don't think this will be a terrible surprise to to folks in the ESIP community, but really some of the basics of assigning data sets DOIs, having good metadata, and version control also, so that different versions of data can be cited separately, really does make a difference in the end, when we're trying to surface this in a report and really show what we did, so that people can have it for use. Those things make the writing and publication of the report significantly easier when they're done well.
I guess I would highlight a point that Leslie Ann made about graphics, the importance of graphics and their interpretability, and Leslie Ann was relaying how important in her own work in relating to stakeholder and other user communities of the assessment the graphics are. And there's a pretty rich literature out there about interpretability of graphics, and anecdotally, we actually had a small investment in the indicator space. If you can remember back 50 minutes to my talk, it's hard at this point, but the indicators, we actually had an activity that slightly tweaked a few of the indicator graphics with slightly different descriptions on the axes, slightly different colors, slightly different aesthetic choices and descriptive choices, and then did polling to see how those tweaks changed the level of understanding that a receiving community would have of those figures. And it was pretty interesting. There were, some unexpected results even that came out of it, where things that a scientist like myself might have seen as increasing complexity actually seem to make some of the data more understandable to particular user groups. And so I think trying to draw on that literature that's out there that looks at aesthetic presentation would be really useful.
So there's a Dave Jones of the Disaster Lifecycle Cluster indicates that he has a question. So go ahead, Dave.
Hi, everybody. Thanks. This was a great webinar. I really appreciate you guys taking the time to put this off. And Erika, thanks so much for continuing the great series within the ESIP Federation. I guess this one is sort of for Leslie Ann. I'd like to focus for a bit just on actually using the information contained in the fourth climate assessment to help make decisions. And you mentioned working with states. Have you engaged, or anybody at US GCRP engaged any county planning commissions and the organizations that maybe set future building codes? I would think there'd be a lot of information in the fourth climate assessment that can help guide building code laws all around the country. And I guess the last part of that question is it the job of the US GCRP to engage those organizations, or do you hand that off and say, here's the report, anybody who wants to engage them should go and do it?
Thanks for your questions, Dave. So a lot of the subtext in your question is actually what I had at the back of my mind when I was leading a lot of this stuff, because I work closely with the transportation agencies here in Vermont, the ag agencies, forest, parks, rec, the planning commissions, and knowing how they want to use the information, especially for things like changing their culvert sizing and items like that, planning for stormwater. How do you actually create brand new plans, change your mitigation plans? Those are pieces that sort of drove a lot of how I wanted the chapter to be written. And I think now the question becomes, how do you take the information, because it's written for the entire region, and help break it down so that it becomes useful for some of the things that they want to do on a state level. And I think some of the underlying products that were created, for example, the state climate summaries, allow us to at least make a step in that direction. Remind me of the second part of your question again, which is about whose job is it to do?
Yeah, it was just, whether or not that's the job of US GCRP. Do you have an engagement strategy to go and really get states and counties involved in using the report so they can really help plan their future? Or, perhaps is it something like the ESIP Federation, with their community outreach group might be able to use US GCRP to make this happen in different parts of the country, or the education committee? It's really just a curiosity question.
Mm-hmm. And it's an excellent question, because, and I'm going to ask Dan to jump in when I'm finished here. In NCA 3, there was a committee called it was something about sustaining the assessment and doing some of the sort of oversight of that. I'm not sure where that committee currently is in terms of its mandate, if it's still in existence, and how that sort of sustaining process will continue to occur. I think there has to be a sort of both a top-down sort of supported at the federal level, but also a bottom-up approach, so that meets somewhere in the middle, because if you're coming only from the top down, you're not always going to understand what the very, very fine granular needs are, but the folks on the local level will, and they may not always have the resources to do all of the things that could be done. And so it's going to take a lot of handshaking, but it's going to take a lot of meeting in the middle. So Dan, did you want to talk about the sustaining part and how that is playing out right now?
Sure. So I'll address that. I guess the other thing that I would add is, because Dave's question is targeted at US GCRP, that US GCRP per se as an interagency organization just has the responsibility to execute and produce the report. the constituent agencies, if you started to get down to that level, you would find a lot of activity at particular agencies, particularly mission agencies like USDA or DOI, for example, that have regional and local infrastructure, like ag extension offices, even at NOAA with the Weather Service to some extent, in DOI with some of the regional science centers and other regional expressions of the agency that in many cases, they pick up the report as a conversation starter, but also as a preliminary statement, fact-based and data-based statement of climate change in particular regions as a way to start interacting on some of the topics like Leslie Ann mentioned, transportation or agriculture or different sectoral issues, energy as well. So I guess the first part of the answer is that it happens at the level of the executing agencies. Hopefully there's good connectivity and we can really use some of those extension aspects to the agencies to reach into the regions and states and localities. And then there's also partnerships with local and regional entities as well, which happens at various levels in the federal government and outside of the federal government. In terms of the sustaining aspect of this, there is an ongoing focus at USGCRP. We have a working group that has been thinking about various issues related to the report's production, which this is a huge thing to execute every 4 years. And so we focus on the sustained activity partially to try to smooth out the huge cycles of effort that go on with the NCAs. But then there's also the sustained aspect that Leslie Ann's alluding to of sustaining connectivity with stakeholders so that we're learning from them what the issues are that they're facing. We're getting these case studies. We're learning about how to evolve the assessment to be more useful for them. But then also, making sure that we're continuing the engagement between our activity on the federal side and what's going on in the regions and with stakeholders at local and regional and state scales. Does that help, Dave?
Yeah, it does help, and it's pretty relevant right now because next whatever the 22nd is, I'm giving a presentation on climate change impacts and planning to the Prince George's County Planning Commission in Maryland. And so I will definitely, I'm already planning to refer to the report. But whenever I give talks, people say, what can we do? I'm not looking to give them an answer like change your light bulb. I'm looking at, giving them an answer is here's how you can engage using this information from the climate assessment to really take a look at your critical infrastructure, make sure that you're, first and foremost is that you're protecting the residents and that you're addressing climate change like it is. It's a crisis, and it's increasing in its severity and its impact. So whether it's through extreme weather or something else. So I think that does help. And I'm just looking to make sure I can couch my answer accurately as to how much USGCRP would get engaged in something like that.
Great, thank you. Megan's given us permission to go over time a little bit. Does anybody else have a question that you just want to throw out there? You can either type something in the chat if they have a question or just speak up. Okay, great. Okay, well, good. I'd like to just thank our presenters for this really wonderful webinar. It's been so informative, and I'm just going to turn it over to Megan.
Great. So just a couple of very quick slides in conclusion. I want to remind everyone that the next Data to Action webinar series or webinar will be next month on Friday, June 21st at 1 p.m. Eastern Time. The webinar is entitled Supporting Better Water Management and Planning in a Changing Climate and will feature Julie Vano, project scientist in the Hydrometeorological Applications Program at the National Center for Atmospheric Research. You can find more information about upcoming webinars on our website, and you can also access webinar recordings on the ESIP YouTube channel. This one will be there shortly. There are a number of ways you can start to or continue to stay involved in ESIP. You can join one of the collaboration areas around themed topics like the Disaster Lifecycle Cluster that Dave represents and the Community Resilience Cluster that Erika represents. You can encourage your organization to become an ESIP partner if it is not already. You can tell others about ESIP using the URL on the bottom of this slide, which is a link to a really great one-pager, a very succinct description of what ESIP is. To receive a once weekly update on all things ESIP and ESIP related, please join our Monday update mailing list. This is a great way to stay in the know about what's going on. Another way you can engage with ESIP is by attending the 2019 ESIP Summer Meeting, which is planned to take place in Tacoma, Washington, July 16th through the 19th. ESIP meetings bring together the most innovative thinkers and leaders around Earth observation data, and a very high percentage of our participants note how important our meetings are for finding collaborators. We have an excellent lineup of plenary speakers that I'm just about to announce in the upcoming Monday update. So if you sign up for that today, you'll hear more on Monday. And the full agenda of breakout sessions will be released next week. Take a look at esipfed.org/summer meeting for more details. There are also a number of exciting events happening in conjunction with the summer meeting, including the Geosemantics Symposium, the Data to Action Teacher Workshop, and the Drone Data API Hackathon. So many more reasons to join us if you can. So with that, I would like to thank our speakers and thank Erika for moderating and all of you for attending. We hope to see you on the next webinar on June 21st.
Thanks a lot.
Thank you, everyone.
Thank you.